In this video, I'm going to talk about replicating data from Postgres to ClickHouse, and I'm going to focus on a tool called PeerDB. Now, replicating data from Postgres to ClickHouse is becoming a increasingly common requirement. Firstly, for kind of data warehousing scenarios where I've got some data in Postgres and I want to get it into ClickHouse to do some kind of offline analytics against it. But also from an application perspective, sometimes people find that their Postgres database and their application is slowing down, and it might make sense to bring some of the data into ClickHouse and do the more like analytical features of your application against ClickHouse to keep the load off of Postgres. So that's a kind of pattern we find as well. Now, if we decide to kind of run these two databases in parallel, what we have to do is think, how do we get data into ClickHouse? Now, we could do that at the application layer by the application kind of writing to both databases or choosing where to write to. Or we could kind of do this at the database level, which is probably a simpler and more reliable solution by kind of cloning and replicating data from Postgres into ClickHouse. Now, if we decide to go down that route, there's a bunch of kind of tools and options for doing it. For instance, tools like Airbyte in the open source space, or Fivetran in the more kind of SaaS commercial space, or maybe a lower level using a framework like Debezium, which is an open source tool for database change data capture. But it's worth looking at a kind of newer tool which is called PeerDB. And I say that for two reasons. Firstly, PeerDB, so it's an open source project and they really focused on Postgres as a data source. So instead of trying to cover all of the myriad of databases out there, they went deep on Postgres, and that's allowed them to build a kind of really high performing, robust and fully featured CDC solution specifically for Postgres. And secondly, PeerDB as a business was acquired by ClickHouse in 2024, and they've already kind of started increasing the level of integration between PeerDB and ClickHouse, and it has been integrated into ClickHouse Cloud. So it feels like it's going to be the most kind of strategic and natural choice if you do want to integrate these two databases. But of course, there are other options out there. So in this video, I was going to start by explaining and kind of demonstrating the open source PeerDB solution, just to give a flavor for how it's working behind the scenes and some of the kind of parameters and options we have. But then I'm going to also talk about the kind of ClickHouse Cloud solution where PeerDB has been integrated into their ClickPipes feature, and hopefully give a flavor of both. So starting with a demo, so here I'm on an empty server, nothing is running. PeerDB is distributed as a set of Docker containers. So if I run my script, run peerdb.sh, we can see it's going to pull down all of the Docker containers and start them via Docker Compose. One of the kind of services exposed here is the PeerDB UI, which is listening on port 3000 by default. So if we navigate to that in our browser, the first thing we need to do is create two peers, one for our source and one for our target. So here I'm configuring the kind of source Postgres peer, specifying a host, a port where the database is listening, and my username, password, and the database where the source data is going to be stored. I can validate that and create the peer, so the connection was successful. And in terms of the target, I'm obviously going to choose ClickHouse. I'm going to call it target_ClickHouse. This particular instance is running in ClickHouse Cloud, so I will specify the host name which they give me, connect on a secure port, and we will specify our username, password, and the database. And for the purposes of this, I'm just going to replicate some data into the default ClickHouse database. Again, we can validate it and create the peer. So at this point, I have two peers, but they're not connected, and we don't have any data to sync between them. So what I'm going to do is create an orders table in Postgres, and we're going to replicate that into ClickHouse. And I'm just going to start by showing that in Postgres at the top and in ClickHouse at the bottom, no orders table exists right now. So the first thing we need to do is create that table, and it's going to contain data for like an e-commerce data set. So it's got kind of payment types, payment amounts, shipping dates, delivery dates, order IDs and stuff like that. And I'm also going to create an index on that table. I'm then going to generate 50,000 rows of synthetic random data. So we're having kind of random delivery dates, payment types, payment amounts, order statuses and stuff like that. So the order will go from pending to shipped and complete. Just to validate that, if I do a select count star from orders, I'm still in Postgres here. We can see we've got 50,000 orders. And if I pull the top 5 rows, then the data looks good. And you can see we have random entries for things like the order status, the payment date, the payment method, and the shipping dates. At this point, obviously, nothing has still been integrated into ClickHouse. We've defined my peers, but we haven't set up any replication process within PeerDB. So that is the next step. So the replication process is called a mirror in PeerDB. So I'm going to create a mirror. We'll use type CDC for this particular mirror. We'll give it a name, CDC orders, and I'll select the source database and the target database. We can tweak some parameters like how often do we sync data and the degree of parallelism when we do the initial load of the orders, but I'm going to leave that as 4. And then I'm going to select the tables which I want to replicate as part of this mirror. So we chose the orders table in Postgres, and we want to put it into an orders target table within ClickHouse. And we're going to bring across all of the columns which are in the table. So now that mirror has been created, and it will go away and be provisioned in the background. Now, very quickly, if we move to this initial copy screen, we can see that already the 50,000 rows have been replicated from Postgres to ClickHouse. So that happened within kind of 5 to 10 seconds, so remarkably quick. To validate that, if I flip back to my ClickHouse Cloud session and do a select count star, then I can see that there are 50,000 rows and the data broadly appears to match with Postgres. What I can do just to validate that that has worked successfully is maybe do a kind of aggregation. So I can say how many orders do I have for each status, and we can see that there are 24,136 orders are in completed status in ClickHouse. If I then run the same query in Postgres, I can see that those numbers match, such as a 9926 in ship status on either side. So that replication has worked. It was very quick and it was seemingly accurate based on that aggregation. So having kind of loaded the backlog of data, what I now want to do is load some kind of new records as they're inserted into my Postgres database. So for a start, I'm going to generate another 10,000 random rows in my Postgres orders table. If I flip back to the UI, I have to refresh a few times, but we can see that the batch has been identified and it started at 1841. If I refresh a few more times, then sure enough, that 10,000 rows have been synced. And if I do a select count star within ClickHouse, you can see we're now up to 60,000 rows. If I now insert another 40,000 into Postgres, sorry, this is going quite quickly, we can see that the batch has been identified and now has been fully loaded. It took 26 seconds, and we are now up to 50,000 rows have been synced. So that's 50,000 have been synced by CDC, and 50,000 have been synced during the initial load. And if we run those aggregation queries on both sides, then sure enough, the numbers still match. And we have a kind of visual representation as to how the orders have been synced here. So the next thing is about updates and deletes. So what we want to happen is when we update the data on the Postgres side, we would also like those updates to be reflected in ClickHouse. So here what I'm doing is setting an order status to cancelled for one particular order. After a moment, that batch will be identified by PeerDB, and after a few refreshes, you can see that the one row has been synced, and that one row was of type update. If I change back to my ClickHouse session, I'll rerun the aggregation, and we can see that we have one order which is in cancelled state. So the update has occurred, but We do have to remember that we have a replacing merge tree as the table engine for this particular table. So if we add a final, we can simulate what will happen during the merge, and we can see that the order has changed from completed to cancelled. Next, in terms of deletes, so the way PeerDB handles deletes is as a logical delete. So here I'm deleting from orders where order ID equals 2. Again, I'm going to flip back to the UI. We will refresh a few times, and again the row has been synced, and that was of type delete. Now the way this works is because it's a logical delete, PeerDB has added a column called PeerDB is deleted, and if I select star from orders where PeerDB is deleted equals 1, we can see that it was order ID 2, which is in the deleted state. So we have to kind of be cognizant of, the table engines that we are using and the fact that we have logical deletes and things like that as we use the data. The other thing I wanted to show here is, so far we've been creating these kind of peers and these mirrors via the PeerDB UI, but a cool feature of PeerDB is that we can also control it via a kind of SQL interface. So here I'm going to connect to PeerDB using the pSQL command line utility, and first I'm going to paste some SQL which is going to create the source peer, so the Postgres peer. We have to include like a host and a user and a password inline here as we do this. I'm then going to create my ClickHouse peer, my target peer, and of course I will change this password before publishing the video. And then I'm going to create the mirror process, so that's the third step where I'm mapping from source orders to target orders. And then having done that, when I flip back to the PeerDB UI, I can then see that this CDC mirror and the underlying peers have been created as expected. Looked at PeerDB from an open source perspective, and the idea is that you would be responsible for cloning it, finding a server and running it, and then kind of operating it and maintaining it. Now, what ClickHouse have done is kind of integrated PeerDB into ClickHouse Cloud, and that gives you the option of kind of setting this up really easily with a few clicks, but probably more importantly, having it ran for you. And if you think this integration process, it could be quite critical for your app. If it goes down, it could break your kind of production app or break your kind of data and analytics infrastructure. So there is an argument to be said that offloading something like this to a kind of cloud managed service is worthwhile. Particularly if you do run ClickHouse Cloud, I think it makes sense to look at the managed option. So what I wanted to do here was just demonstrate how this looks when it's been run within ClickHouse Cloud, just so we can kind of compare and contrast the two user experiences. So I'm going to start here in a kind of new ClickHouse Cloud account where we have one instance running. And if I flip back to Postgres, we can see that this is the same orders data set as we've been working with in the previous section. We have random order dates, shipping dates, delivery dates, order statuses, payments, and stuff like that. So it's that e-commerce order data set. If we do a select count star, we can see there's about 1.5, exactly 1.5 million rows in the data, in the source data. So enough to play with, though obviously not huge. So what we want to do is within ClickHouse Cloud, if you go to the data sources section within the instance, I'm going to create a new ClickPipe of type Postgres CDC. We have to give the ClickPipe a name and a description. And instead of configuring peers as we did last time, we simply have to specify our kind of source connection details. So that includes a host, a port, a username and a password, and the database which we would like to replicate. We get a few warnings about the Postgres settings, but we'll just accept the defaults for now. Next, you have to choose what's called a publication, which is a Postgres CDC feature. I'm just going to leave that blank for now, and ClickPipes will create one for us. And then we have some settings like the sync interval, the batch size, and the degree of parallelism. I brought the sync interval down slightly for the purposes of the demo, but otherwise accepted the defaults. Next, we have to choose which table do we want to replicate from Postgres, and the name of the table in ClickHouse I want to replicate into. It's called orders, and we're going to bring across all of the columns. And then finally, we have to choose a role associated with the replication user. And it's probably best practice to lock this down. But for now, for the demo, I just chose full access. Now we can see that kind of ClickHouse Cloud is provisioning the ClickPipe is the correct terminology. And if we click on View Tables over here, this will give us visibility of what is happening on that initial snapshot. So already after a few seconds, we can see that 600,000 rows have been replicated. Another 10 seconds or so, we're up to 1.2 million rows have been replicated, and now we're up to 1.5. So within less than 20 seconds, the entire data set has been replicated from Postgres into ClickHouse. And in the last demo, we did some kind of simple aggregations to show that that data had been replicated as we expected. And here we confirmed within ClickHouse Cloud, we have 1.5 million rows, and the data broadly looks good with the expected randomness. So next, we've done that batch snapshot load, but we haven't actually synced any rows which have been inserted, updated and deleted. So let's just demonstrate how that looks. Initially, what we could do is update a few orders. So if we choose a few at random, and what I'm going to do is set the status to cancelled, which is a new status. So first we'll do is 510009, and I'd like to pick one more. So we have 2 in the batch. So if we give that a second, then we can change back to the ClickHouse Cloud UI, and by the time we get there, we can see that the 2 updates have been synced and integrated. So the chart is updated. We can see when did the batch start and finish. I sometimes find those durations a little bit misleading. I think that's including kind of wait time in there. Now, if we do select count star against a table, we can see that we're actually up to 1.5 million plus 2 rows. And the reason for that is because we have to remember it's a replacing merge tree is what we chose. So if I add in a final, then we can simulate what would happen after a ClickHouse merge. If I go and look at this specific order, then as of right now, we'll have 2 because we have the original record and the new record. If I add in a final, then we will see that after the merge, the old record will be replaced with a new one. So you do have to be, cognizant of what table engines you're using and the semantics around them when we're integrating Postgres and ClickHouse in this way. Then in terms of deletes, we showed this on the last video, but we basically have logical deletes. So I'm going to delete one particular order with an order ID ending with a 6. If we wait for a second for the order to replicate, you can see it's currently 2 rows. And now the deletion event has replicated. If we go and check the orders table, and I'm going to check that flag, PeerDB is deleted, and we can see that we now have that one order ending in a 6 has been logically deleted. So of course any reports or analysis we do has to take into account the fact that we only have a logical deletion here. So what we've done there is we've explained what PeerDB can do for you in terms of integrating Postgres and ClickHouse, both for that initial migration, but then on an ongoing basis as you insert, update and delete more data within your Postgres database. We looked at the user experience of working with PeerDB open source by setting it up, inserting, modifying some data and observing how that is replicated into ClickHouse. We then showed the same thing within ClickHouse Cloud. So we set up a ClickPipe, we modified some data, and we observe the events being quickly replicated into ClickHouse. So hopefully that makes sense, and you can see where this could add value. If you have one particular application where performance is struggling, purely against Postgres, then you could potentially offload some of the load onto ClickHouse. Or if you're doing a more like data warehousing scenario where I want to get data out of my Postgres database and into ClickHouse for kind of later offline analytics, PeerDB or the ClickPipes solution definitely could have a role to play in helping you do that. So thank you very much.